This video is going to have a look at adjacency matrices, which we use to determine connections between different objects. An adjacency matrix is a matrix that represents the number of connections between objects in a network or the number of edges that connect the vertices of a graph. So we're looking at connections being made between different objects, and we're originally starting with those connections being looked at a graph level. Using the graph, it allows us to determine the number of connections either directly or via different objects. So having a look at our example, I can see that I can go from A to D directly, or I can go from A to D via B. So that's an example of going directly, so go directly from A to D, or indirectly via another object, so from A to B and then to D, ending up in the same place, either directly or via a different object. So if we are going directly, that is what we call a one-step direction. If we're going in between one or more objects to get to our destination, that is an example of a two-step connection. So what we can do is we can take these diagrams that we start off that show our connections and make a matrix that's going to help show us those directions that we can then use to perform some calculations. So let's have a look at what type of matrix we can form based on the diagram that we are provided. And having a look, we can see that the diagram that we're using as our example before, we've now used to make a matrix. So having a look at that matrix, we can see that up the top and down the sides, we have the letters A, B, C, D, and E, and that comes from our diagram. We can see we've got letters A, B, C, D, and E on the diagram. Inside the matrix, we can see that we've got numbers 0 and 1. 0 will mean that there is no path or no connection between the two letters, and a 1 means that there is one path between the two letters. As the diagrams and the connections make more complicated, we might have 2 or 3 direct paths in between our objects that we can record using a 2 for 2 paths, a 3 for 3 paths. So how we use our matrix, we can see that down the side, it's our starting point. So what object are we starting from? And along the top, it is what object we're going to. So for example, I may want to go from object D to object B. So I start off down my side, finding out where my D row is, and starting there, and I look there, and then I'm going to B. So looking for my B column, because that's where I'm going to, and I can see that where those two intersect is going to be my number of paths from D to B, which is equal to 1. So I can see from object D to object B that there's only one path I can go. If I go back to my diagram and I'm going from D to B, I can see there's only one direct path that I can take. You will note in our matrix that diagonally down the matrix is a line of zeros. They're there because we cannot travel directly from point A to point A, or from point B to point B, or from point C to point C, etc., etc. So when we're looking at one path matrices, we will always expect to see that diagonal line of zeros, meaning we cannot go directly between the same object. So the last piece of information we can tell from a matrix is that the number of paths leading away from an object or the number of paths leading to an object. So for example, if I wanted to determine the number of paths that are leading away from object C, I can have a look at row C and I can add up my total. And I can see that if I add up all my ones, I'm going to have a total of 3. So that means there's going to be 3 paths leading away from object C. So if I go to my diagram, I can see that I've got object C and I've got 3 paths leading away. I've got a path to A, a path to D, and a path to C. So by adding up the horizontal line corresponding to the object, I can see how many paths are leading from it. The same if I add up a column, I can see the number of paths leading to an object. So now that we've had a look at how do we interpret an adjacency matrix, let's have a look at how we can prepare one from a diagram that is provided. So in our example, we've got a diagram that shows the number of roads connecting 4 towns, A, B, C, and D. We want to construct an adjacency matrix that is going to represent this information. So first I'm going to determine what my adjacency matrix is going to look like. And because I've got 4 objects in my diagram, I'm going to have a matrix that's going to have an order of 4 by 4. And that's going to be the 4 towns along the top and the 4 towns along the side. So I can draw a bit of an outline for my matrix that's going to help me to complete my adjacency matrix. So now I've got an outline for my matrix that is going to have 4 columns and 4 rows. And I'm going to go ahead and label those rows and columns A, B, C, and D to help me to complete the matrix. A, B, C, D, A, B, C, D. I know that I'm not going to have any direct paths between the 2 objects, so diagonally down the center, I can go ahead and enter in zeros. So next I'm going to start filling in my paths, and I'm going to start looking at my row A, and I want to see from object A, where can I go directly? So going back to my diagram, I can see that I can go from object A to B, I can go from object A to C, and I can go from object A to D. So I can go to each of the 3 other objects. So I can go ahead and update my matrix. So from A to B, there is one path. From A to C, there is one path. And from A to D, there is one path. Next, I want to move on to object B and have a look from object B, where can I go? So going back to my diagram, I can see I can go from B to A, and I can also go from B to D, but I've got 2 paths that go from B to D. So when I complete my matrix, I'm going to put in a 2 between B and D, and I've got no paths from B to C. So I can go ahead and update my matrix. So I've got 1 path from B to A, I've got 0 paths from B to C, and I have 2 paths from B to D. So moving on from object B and going to object C, and I can see that for object C, I've only got 1 path, and that is going to go from C to A. I've got no direct path from C to B or from C to D. So I can go ahead and again update my matrix. I've got 1 path from C to A, 0 paths from C to B, and 0 paths from C to D. And then looking to complete my last row from object D, having a look at my diagram, I can see that I can go from object D to object A, and I can go from object D to object B, and again I've got 2 pathways between those 2 objects that I can travel on, and I've got no pathways from object D to object C. So I can now go ahead and finish my matrix. So from object D to A, I've got 1. From object D to B, I've got 2. And I've got 0 between objects D and C. So we can see there that that is my completed matrix for the diagram shown. That shows me all the direct paths between my 4 objects. So that is an example of how to complete an adjacency matrix using a diagram that is provided.